Hello, my name is McGinley, and today I will be reviewing injection molding and 3D printing. For the agenda of this presentation, I will be going over the current status and brief explanation of injection molding and 3D printing, a new process of additive 3D printing, advantages and disadvantages of both manufacturing processes, manufacturing readiness level assessment to determine the best suitable manufacturing process for the company, and recommendations and summary. Now, what is injection molding? Injection molding is a process where melted plastic is injected into a mold under high pressure to form a specific shape. Once cooled and hardened, that part is ejected. It is a fast, precise method to use for mass production items ranging from toys even to automotive parts. The image on the right shows plastic granules loading into a hopper, then going through a heater that is then injected into a mold cavity, which is then clamped together, and output is your injection mold. 3D printing, on the other hand, is a process where material is added layer by layer to create a 3D object from a digital design. It is used to make custom parts and prototypes, offering flexibility and the ability to create complex shapes. The image on the right shows filament being loaded into the extruder. The extruder is then able to control the amount of filament precisely. The system moves the extruder head to be in position for printing the next layer. The hot end melts the filament to be in a fluid state. The object is then being constructed layer by layer on top of the heat pad. After a little overview of injection molding and 3D printing, here are a few of our company goals. A couple of the goals include investing in a manufacturing expansion of the company, producing high quality products, and providing efficient all-around production for our company. When comparing and contrasting injection molding versus 3D printing, they both have their pros and cons. For injection molding, the pros include high production speed. The injection molding allows for rapid production of larger quantities, perfect for higher volume needs. Consistency and precision. Each part is made to exact specifications, ensuring uniformity and tight tolerances. It can produce complex shapes, capable of molding intricate and complex designs that are hard to achieve with other methods. Low cost per unit. Once the mold is created, the cost per part is significantly reduced, making it cost-effective for large runs. Larger material variety offers a wide range of materials, including plastics, metals, and different for product needs. Minimal waste. The process generates very little waste, and excess material can often be reused. Strong, durable parts produce robust, long-lasting parts suitable for functional and high-performance applications. And then lastly, we have low labor costs. The process is highly automated, reducing manual labor and keeping costs down. Moving on to the cons of injection molding. High initial cost. The upfront cost of creating molds and setting up machinery can be expensive. Limited flexibility with new designs. Once a mold is created, making design changes can be time-consuming and costly. Complex setup. The process requires detailed preparation and a setup, which can take time and expertise. Design limitations. Certain design features like undercuts or complex geometries can be challenging or impossible to mold. Not ideal for small volume production, injection molding becomes cost-effective only when producing in large quantities. Long lead time for tooling. Creating and testing molds can take weeks or even months, delaying production. Design limitations for larger parts. There are practical size limitations on the parts that can be molded, especially for very large items. Material restrictions. Not all the materials are suitable for injection molding, limiting material choices for some products. Shrinkage and warping. Parts may experience slight shrinkage or warping during cooling, affecting precision and fit. Environmental impact. Injection molding can generate waste, and the use of certain plastics may not be environmentally friendly. Moving on to 3D printing. The pros for 3D printing include design freedom. 3D printing allows for high, intricate, and complex designs that would be difficult or nearly impossible with other methods. Customization. Each part can be customized easily, making it ideal or unique. Low setup costs. There's no need for expensive molds or tooling, besides the machinery or the equipment used to actually make the 3D prints, making it affordable for small runs or prototypes. Rapid prototyping. You can quickly turn designs into physical parts, speeding up the iteration process. On-demand production. Parts can be printed as needed, reducing inventory and storage costs. Material flexibility: a wide range of materials, including plastics, metals, and composites, can be used, providing flexibilities for various applications. Reduced waste: 3D printing creates parts layer by layer, minimizing material waste compared to traditional subtractive methods. Tooling-free production: there's no need for molds or special tools, making it simpler and faster to create new designs or prototypes. Moving on to the cons of 3D printing, which comes with a slower production speed. 3D printing is slower compared to traditional methods. Moving on to material limitations. 3D printing materials are often more limited in performance and selection compared to traditional manufacturing, like injection molding. Surface finish: parts may require additional finishing to achieve a smooth, high-quality surface. Size constraints: 3D printers have size limits, which can restrict the production of larger parts. Limited strength: 3D printed parts may not have the same strength or durability as those made with traditional methods like injection molding. Post-processing requirements: many 3D printed parts require additional steps like cleaning or curing or removing supports, adding time and cost to the process. High cost for larger volumes: 3D printing remains expensive per unit for high volume production, making it less cost effective than injection molding. Printer maintenance: 3D printers require regular maintenance, and repair costs can add up over time. Moving on to costs for both of these manufacturing methods. For injection molding, the larger costs seem to be tooling, equipment, and molding costs. Now for 3D printing, the larger costs include materials like the filaments, post-processing costs, and labor for those post-processes, waste, and machine depreciation. Next, I'll talk about the manufacturing readiness levels for each of these manufacturing processes. For injection molding is considered to be at a manufacturer readiness level of 9 at a full rate of production. This is because injection molding is known to be a well-established, widely used, and highly optimized manufacturing process used for mass production. There are many factors that place injection molding at an MRR level of 9, which include technology, full-scale production, optimization and automation capabilities, stable supply chains, and proven reliability. 3D printing, on the other hand, is considered to be at a manufacturing readiness level of 7. The MRR level can vary depending on the type of 3D printing, the materials used, and the complexity of the products created. Some of the factors that place 3D printing in this range are advanced technology, low volume production, material advancements, process optimization, prototype to production, and post-processing needs. In conclusion, my recommendation for our company's needs is injection molding. Reason being is it's more cost effective for producing a larger volume of product. With an MRR level of 9, injection molding is a highly mature and reliable process that's proven to work efficiently at scale. Once we have the mold set up, the cost per part drops significantly, and thousands or even millions of parts can be produced quickly, with great consistency and durability. On the other hand, 3D printing is better for small batches or prototypes, but it's slower and more expensive when you need to make a larger volume of product.